In this video, I'm going to show you how to use the Small Sample Corrections program. The button for it appears down here, so I'll click on it. When I do so, a set of instructions appears in the description box for how to use the program. We'll be inputting information on it in the input values box here. Let me give you a little background for it. Monte Carlo studies that have suggested that the chi-square test a model fit in SEM can be biased when the ratio of the sample size to the number of estimated parameters is larger than 2. This is often likely to occur when we have a small sample size. Several statisticians have suggested corrections to the chi-square index of fit to adjust for the bias. The current program implements 3 of these approaches: a Swain correction, a correction proposed by Yuan, and an F-ratio approach described by McNeish. The details of each approach are provided in my book, where I discuss the strengths and weaknesses of them. In the current case, I'm going to enter the following information into the input box. First, I indicate the number of variables in the model. There were 12. Then I indicate the sample size. The n was 84. The model chi-square from the output is 67.723. That's the traditional chi-square. The model degrees of freedom is 51. The number of free parameters is usually provided on the output, and in this case it was 27. And finally, I need to give the independence or baseline model chi-square, which from the output was 264.488. I then click on Register Input to generate the syntax. The syntax appears in the R syntax box. I copy it to the clipboard. I start R. On the left here, I'm going to hit Control V to paste the syntax, and the program will execute as the syntax are pasted. The commands appear in red and the output appears in blue, so we want to focus on what appears in blue. This was the original chi-square and the p-value for it. The Swain adjustment, if it's equal to 1, means there was no adjustment. As it deviates from 1, it means there is an adjustment. In this case, the Swain chi-square was 63.59, and the p-value for it was 0.11. And then the Swain chi-square is used as a basis for providing a number of global fit indices here, the traditional fit indices. The Yuan chi-square was 66.11, and this is the p-value for it. And the McNeish F-ratio was 1.33 with 51 and 83 degrees of freedom, and it had a p-value of 0.12. I like to use a sensitivity approach where I apply all 3 methods as appropriate and see if my conclusions are the same. If so, the use of one method over another is moot. If not, I move forward with some tentativeness because I know that my conclusions may be method dependent. If non-normality is worrisome, you can use a robust chi-square index in place of the traditional chi-square in the program. Also, in some cases, you can apply the methods to a nested chi-square test to perform tests of individual path coefficients. For details, see my book. Okay, that's it. Thanks a lot.